VLPSos here. This is a video lesson for Python programming indexing. These videos are made with the intention that they may be paused so that you can practice. We use indexing to find or reference a piece or a part of a list or string. And you can see that I have assigned the variable alph a string, which is the alphabet. The square brackets or square parentheses are used as indexing brackets. The number inside is the position that is indexed. For example, if we referred to the alph variable and used the indexing brackets directly after the name of the variable, and inside we put a number like 19, then that would be indexing the 19th position within the alph, in this case, string. And if we wanted to run our program and print what was in the 19th position, we can put this inside of the print function and save and run and observe. T is a single letter. T was in the 19th position of this string. T is not necessarily the 19th letter of the alphabet, it's the 20th, because the 19th position is found starting with a position number of 0. In other words, in the alphabet, with the way that a computer language indexes, the A in the alphabet is in the 0 position, and then we count up from there to get to 19, which is where the T is located. And we can make a note of that. The initial position in a list has an index of 0. Lists and strings start with a position of 0. We can verify by printing from alph with an index of 0, what is located in the 0 position ought to be the A. And we can see that when we run the program, the A got printed. We can use a colon to mean through in an index. Let's give some examples. If I refer to the alph variable with the indexing brackets and then use a 2 for the second position with a colon and then a 5, we mean an index of 2 through 5, but not 5. I'll show you what I mean by running the program. Alph indexed 2 through 5 printed C, D, and E. If we take a look at the alphabet, the C is in the second position. Remember that A is in the 0, so B would be in the first, and it's C that's in the second position. We saw the D also printed in the third position and the E in the fourth. What did not get printed was the F in position number 5. Even though our index shows 2 through 5, the end of the index, the upper bound of the index, did not indicate a position that got printed. And this is something that we need to get used to in the programming language, not just Python. Lists start with a position, and we often go through until we reach an end, but at the moment that the program reaches the end of the list, it doesn't use that because it's using the upper index as a signification to stop processing. So once it gets to the 5th position, it doesn't print it, it stops printing positions. Let's see this again. I'm going to print alph, and in this case, we won't include a number. We'll go straight to the colon and 8. This notation implies that we are going to list or index from the starting initial position through 8. but not 8, because the 8 is showing the computer where to stop, and it doesn't get included in the process of printing. So what is in the 8th position of the alphabet? We can count 0, 1, 2, 3, 4, 5, 6, 7, 8. The I is in the 8th position, so if we're going to index from the initial position through 8, we should see everything up to, but not including I. Let's give one more example. We're going to index ALF from 8 and then a colon. And if there is a number missing in a range, then it implies that we start with 8 through to the end. And we can say, if we, after we fix the error, that we saw the I in the 8th position and then everything else in the string until the end of the string. And we can step through a range with a third number in the argument. Again, we'll give an example by printing from the ALF string the index starting at 0, going to position 25, the end of the alphabet, and a third number in the index is a 2, which we call the step, which means that we're going to skip once we start and only print every other letter in the string or every other position. What gets printed was A in the initial position 0, and we skip over B to get to C, skip D to get to E, and you get the idea. We're skipping letters until we get to the end. Again, this is an index that we can read 0 through 25 with a step of 2. A little bit more about stepping. We can go backwards if the step is negative. For example, we'll print indexing ALF. In this case, we're going to start at a position 25, which is the letter Z, and go to position 0. And we're only going to see something if we step backwards. If we don't include a negative in the step, in this case a -1 is we're not going to skip anything, but the negative allows us to go backwards from position 25 to 0. We can see that we get the alphabet in reverse. But we had to stop at a position of 0, and if 0 is our stopping point, it's used as a stopping point and does not get included in the print, which is why we're missing the A, the stopping point of position 0. And we can index with lists, which is very useful. I'm going to define a list, and a list is a data structure that uses the square parentheses as well. I'm going to make a list of strings. A list has positions, like the letters in a string have positions. In this list, the position of the string Archimedes is the initial position in the list. It has a position number of 0. I can index this list with the indexing brackets. I refer to the variable by name and then immediately end with the indexing brackets. And if I put a 1, then I mean to refer to the item or element that is in position number 1 within the variable A list. Position number 1 is not Archimedes. If we're going to see it when we run, we'll put this into a print. And in position number 1, I can see was Hypatia. Archimedes is in the 0 position within this list. Moving on. What if we wanted to print the last element in the list? And we didn't necessarily know how long our list was. The last element in this list is Abelard, and it's in position 3. But if we didn't know how long our list was at the moment that we wanted to index the last thing in it, maybe because the size of our list is changing as the program runs, then we can use this kind of index. We're going to refer to the length of the list, so I'm going to print so that we can see what the length of a list is, putting a list into the length function. And if I wanted to print that last thing, then I'm going to print from the a list something that is going to be indexed, and it will be the index which is the length of a list, but I need to subtract 1 because the length of the a list in this case is 4, but 4 is not a position number that exists in a list of length 4. If a list contains 4 elements, then its position is going to be 0, 1, 2, and 3. Which means that if I'm going to use the length of the list to index the last thing, I need to take 1 away from it. And we can see the evidence of this. The 4 is the print of the length of the list, and Abelard, we can see in our code, is indeed the last element in that list. Python handles an array or matrix as a list of lists. In other words, there are data structures in other languages that are often called arrays or matrices. Matrix is singular. In Python, an array is created as a list of lists and is not itself a different data type. So what we mean by an array, we'll give an example. I can create an array as a list that I put lists into. So I have the square parentheses to create a list, and what's going to go inside are 3 lists. So I have list brackets separated by commas inside that list. I can put information inside those lists like the numbers 1, 2, and 3, 4, 5, and 6, 7, 8, and 9. This is a list of lists. It's how Python handles arrays of numbers. And if I do a line break after the commas, I can see an arrangement like a rectangle, or in this case a square, of the data in these lists of lists. So this square has an index. If I use an index, I could refer to a list inside of the array. In this case, if I refer to the array with its variable name and then include brackets right after, I'm indexing my array. If I put a 2, then I'm looking for the element in an array in position number 2. An array has 3 things in it. Remember, the array is the outer list, and what it contains is 3 lists. So the one that is in position number 2 is the last one. And indexing it in this way means that I'm referring to that entire list that is in position 2. I'll need to print it so that we can see it. I can see that the third list, which is in position number 2, has been printed, and it contains the numbers 7, 8, and 9. If I wanted to refer to a part of that list, then I need a second index. So I'm going to double index an array. I'm going to look at the element that is in the second position, which is itself a list, and then my second index is going to look at an element within that list, in this case position 1, which I anticipate the 8 to print, because remember 7, the initial element in the list, has a position number of 0. So here's an example of a double index. It's indexing an array, a list of lists, and I can verify that 8, which was anticipated to print, is indeed found as in the second element and first position. Make a note. We think of the elements as having a row column position. The 8 is in the second row and first column, remembering the ordering starts at 0 and not 1, and we can access the values in a list of lists with a double index. Indexing is an everyday, all the time essential of programming. We will make much use of it in the future, especially when we introduce for loops. Now you saw how to use indexing to print an inside range of a string. Set a variable equal to your full name, then use indexing to print just your middle name. If you don't have one, make up a nickname to put in the middle, like Sauce in the name Thomas Sauce Sosnovic. And second objective, you saw how to write an array and use a double index to access a value within it. Write your own list of lists that is different than the example, and demonstrate using a print, using a double index to print a value within it.